welcome back to Game Day at Rapid Plus TCT 2023. I'm Brandon Ribic, the Technology Director at America Makes, and I'm really happy to be joined here this afternoon with a number of folks from industry. We're going to be talking about a sports application today. This is kind of interesting, a little bit different for sure. Trying to understand the utility that AM technology presents for this application and really how this team came together. So before I get too far ahead of myself, I want to give everyone a chance to kind of introduce themselves. So Nadine, how about we start with you?
Sounds good. Thank you, Brandon. I'm Nadine Lippa, and I work for Wilson Sporting Goods in the Team Sports Division, and I'm Innovation Manager.
My name is Alex Rhodes, and I am the COO of General Lattice, and we are out of Chicago.
I'm John Walker. I work for EOS, and I'm the Business Development and Key Accounts Manager.
And I'm Mike Shore. I work for Dimension. I'm the General Manager for North America.
And I'm Laura Griffiths, Head of Content at TCT Mag.
Well, thanks everyone for being here. So, yeah, I think some folks have seen this, some folks may have heard, but really, I think this is an opportunity for us to kind of share some of this story. So, we have a additively manufactured basketball that Nadine has here with her today. And I was talking to the team just before this, and there's quite a story behind it. Not only the innovation, but the pace at which the team came together and collaborated. So I was curious if each of you could kind of share some perspective on what did it take to really bring this to fruition, bring this to a realization.
Well, I can kick it off and then... Yeah, so basically this was an idea from Wilson Sporting Goods. So I started in 2018 at Wilson, and my director, Kevin Krishak, asked me to come up with different ways to make a basketball and completely change how it's made. And one of those ways that I looked into was 3D printing. And so started to get involved with the various people at this table and the companies that they represent. So I'll let each of them touch more on how we got to know each other.
Sure. So Wilson was introduced to us about a little over a year ago, and we got involved in the project, and we were asked to kind of provide the computational design support for iterating through these the ideas that they had and some of the work they had previously done. And so we came on board to help from that end and worked with our computational team, GL Labs, to support.
From an EOS standpoint, we've been working with Wilson with some of their different business units probably since 2018 or even earlier. And for us, we had heard the concept of an airless ball kicked around. And we had started and stopped with Wilson, different materials. There's a lot of innovation that goes into this ball. So it was very exciting to see the basketball come to life for the dunk contest. And EOS provided the machines to build the ball, the material, and then we actually built the ball in our office in Texas that was used in the dunk contest.
Yeah, and very similar to the EOS side, we Dimension and the various folks from Wilson, we got to meet each other over a couple of different trade shows and just kind of quick interactions, and being on the back end of all of this. We've always had some involvement to an extent to just kind of help create different visualizations to the product and also different finishes, of course. And for this one, we got excited real fast because of the fast pace that came around, and then we got involved early enough where we had the three of us back and forth continuously, even daily, sometimes more than a few times a day, to talk through what we were learning through each process and continue to push that in that really tight timeline. So, yeah.
Yeah, so it's amazing to understand how the team came together. I think each of you have your respective expertise and your focus and function within the team, and so I think the timeline was fairly tight on this, right? From ideation until delivery of the final product form. About how long was it again?
When General Lattice got involved, I think we had the goal of the slam dunk contest, right? Something like that. And so that was about 12 months. So, to really go from that to meeting that goal and having such a successful outcome, I think was pretty incredible.
And from an EOS standpoint, we had tried different material recipes for Wilson, probably over that same time period, but we weren't sure we were actually going to be the machine OEM of choice for the ball until maybe Thanksgiving-ish. And so probably, with the holidays starting sometime in December, and then the dunk contest is in February. So, probably less than 8 weeks, and we factor in the holidays, maybe it was more like 4 to 5 weeks of real business time. And that's really where the crazy pace came from, where Wilson would define what they wanted to change and test in the basketball. General Lattice would create the file. EOS would print the ball. Dimension would post-process and finish the ball. Then it would go to Wilson's facility in Ohio where they would test the ball. Then they would send that information back to Nadine, who would then decide what we needed to change next to try and improve the performance. And basically we got to a point, again, somewhere in January, probably every 2 or 3 days, we were able to print, finish, test, print, finish, test basketball in that crazy order. And it was really also as well, Nadine's in Chicago, General Lattice in Chicago, EOS in Texas, Dimensions in Texas, the testing facilities in Ohio. You had 5 different companies and sites working together to make this happen.
Wow. So I heard a couple times, we have the design, we have a design tools, a design method, a process, post-processing, and so, all that folds into performance, right? I guess, aside from those things, are there other factors that went into kind of leading to the performance that you were looking for this basketball, or what else goes into a basketball?
Sure. Yeah, so I would say compared to just some person off the street who would make a basketball, what Wilson considers, we have a whole battery of test methods that we use, and we bring decades, 100 years of making basketballs. So I think from my perspective, a very unique aspect of this is making sure the ball bounces the same throughout the ball. So depending on which method you print it, how you finish it, how you design it, all these attributes that you just mentioned, and then making something that's spherical that is in and of itself, it's not perfectly radially symmetrical, but you want that radially symmetrical experience. So that's where we kind of came into play. Definitely the other people present here came into play on that as well.
So I noticed, so for those of you at home, you can't actually touch the ball, but it's fairly smooth. I mean, is there a reason for it being like that smooth kind of texture on the outside?
Yeah, I mean, when Nadine came to us and kind of presented the idea of what this was going to be used for, right? We are doing a slam dunk contest. Now we automatically have an athlete involved. Now we have this interaction and experience-driven customer at the end of the day. And it's not just all of us trying to work together to figure out how are we going to print it, how are we going to meet the weight specifications, how are we going to meet bounce. Now we have to say, what is the athlete going to think when he touches it? So smoothing it through the Dimension Power Fuse, we're able to kind of create a little bit of a control process on what level of smoothness to create a resemblance of an actual product that Wilson's already producing.
That's interesting.
I can add on to that too. I also just want to add on to that because I had 2 colleagues in particular from Wilson's side that were really helpful in this conversation. So I have a colleague who is not here today, Hudson Van Treese is our industrial designer, and his job is to relate what I'm doing on the engineering side back to the athlete from like a design, what does the consumer want perspective. So he also talked to Mike and Mike's team and figuring out exactly what the right smoothing level was. And then we also have player insights and product line manager, Ben De La Cruz, who actually has the coolest job in the world. He gets to talk to all the athletes, and he was out there helping us play test very, very discreetly and getting that feedback as well.
Yeah, that's awesome. Thank you. And so, one thing I'm curious about. So, today here we're sharing with everyone. We're getting the word out. I guess in terms of other kind of forms of dissemination of the success and the progress that's been made here, I guess kind of what are the other plans there in terms of kind of, or I guess where do we go from here, right? Considering your success so far.
Sure. So at least from the project as a whole, obviously we have it here at Rapid today, and happy to be getting feedback in real time from people as they come to each of our vendors' booths, and we're collecting that information and going to have conversations about what everybody said. And my hope, and what the team is having preliminary conversations on, is how do we move this forward? How do we do the next thing? And right now we're in that formulation stage of what, once again, coming back to the partnership, what is everyone capable of doing, scale up wise, what are our limitations and how can we work together to make this more than just the Airless prototype, make it prototypes or products.
That's exciting. That's exciting. So did you have something? Yeah, please.
So I think this has really captured the imagination of so many people, not just in the additive manufacturing industry, but I speak to friends at home and this is the thing that they want to talk about within 3D printing. And I'm just wondering, how do you feel about the kind of impact this is having on getting more eyes on the technology and what is possible with additive manufacturing?
So one of my best friends growing up, hockey player, so basketball is maybe our natural enemy, but my neighbor growing up was basketball player, star in my high school. And, I kind of knew this was coming, and I said, hey, Nick, make sure you tune in and watch the dunk contest tonight. And the thing that really blew my mind is like every 3 to 4 days after the dunk contest, he would text me, and you could tell he had just been spending his last week thinking about the basketball. And he's like, well, I didn't see him shoot him. Does it fly correctly? Or like, would it bounce like a normal basketball bounces? And every day it was just another question. So for me, we've done some pretty cool stuff at EOS, and this was really the first time that somebody not interested in 3D printing took an interest in it and did something more than say, oh, that's really cool. Like they really wanted to understand it. And he's like, is it quiet? Is it loud? How does it function? So just seeing people's curiosity peaked was definitely a very new thing with this project.
Yeah, I would just add, like, this is one of the most relatable applications for additive manufacturing to anybody in the general market. So getting people exposed to something and understanding a little bit about it and seeing something different in such a relatable application, well, I think it definitely makes more people interested in it, for sure.
Yeah, I'd even toss in more, like, our own platforms and social media, we saw that this was by far the largest or most viewed item that we've had, and as we were saying, it's a relatable product. We can all understand what it should feel like, so we have this imagination around it. And similar to John's experience, I had a lot of my friends and family that don't have interest in what else I do within additive, who come to me and then they're sending me links of, oh, I just saw this video clip about it. Did you get involved on here? And it was just really exciting to see the hype that came out of such a unique product, and it was televised, or it was available to everyone. So,
yeah, thank you, Wilson.
Yeah, for sure. I think another important thing to think about at America Makes, we get to think about a lot of different applications, but I think the essential elements of not only the roles and functions of the members of this team, but a lot of those essential elements go into all additively manufactured products, right? So it's not just I have a concept that I want to work on and think about scaling, but you have to consider the materials, you have to consider the process, the pace at which materials and products can be delivered, and then consequentially, what's the effect on the end game, right? The performance, and then how does that bear in semblance to existing products or other solutions? And so I'm really grateful that you all have had some time to come here and share this with us today, because I think it's a good success story. I think what's really interesting too is that the amount of end product testing that's been involved and the expert resources that have been utilized in order to really try and create an equivalent product, especially in terms of its performance. And so, yeah, it's a really exciting application and a great success story. So thank you all for your time. I really appreciate it, and enjoy the rest of your time here at Rapid Plus TCT.
Thank you.
Thanks.
Thanks.